Okay, for question 12, the keyword to take note is actually word done. Okay, so in this case, let's try to recall the formula to find word done. So word done is actually equal to my force applied. Okay, force applied multiplied by my distance that is moved in the same direction of the force. What does it mean? In this case, if you look at the diagram, the force is actually 10 Newton moving upwards. So the force is actually in this direction. Okay, so the distance moved also has to be in the same direction. Means that if my force is must be parallel to the distance move. So these two has to be in the same direction. So if this is 10 Newton trying to move it up, the distance move is from x to y, so it's actually from the bottom to the top. Okay, so in this case, the distance from the bottom to the top is actually 5 meters. So in order to apply this formula word done, it's actually force of 10 Newton multiplied by distance move of 5 meters. So in this case, my answer will be 50. The unit for word done is actually joule. So my answer will be option D. Okay, just take the force multiplied by the distance move. Okay, let's now move on to question 13. Okay, question 13 is on the topic of talking about making things hot and trying to make toast. So it's actually talking about the topic of transfer of heat energy. Okay, so the question is asking for the main form. So recall there are three types of heat transfer. Okay, heat transfer, you can recall heat transfer is actually conduction. Okay, it's actually conduction. The first one is conduction. Okay, the second one is actually convection. And the third one is actually radiation. Okay, how do we answer question relating to these three types? Because in this case, the question is asking for the main form of heat transfer. In this case, it's from the grill to the slice of bread. So the heat transfer is actually, you look at the direction, it's actually from upward, up, because this is the heat source. Okay, the heat source. So the heat has to transfer from the high temperature to the low temperature. Okay, so how do heat transfer from the heat source on the top to the object which is at the bottom? So this is our question here. So which form is the best? Conduction, it needs a medium. Okay, so it's usually talking about the material. For example, a metal spoon. Okay, so it's a solid, so there must be some physical touch. So the keyword here is called touch. This must be touchable. Okay, for convection, it's usually talking about, it's also a medium, but the medium is very special. It's not a solid. The medium is either water or liquid or gas. Okay, so usually the movement of this water or gas is less dense will move up and more dense will move, or denser will move down. So it will create a convection current. So something less dense will move up, something denser will move down. So this is convection. The last one, which is radiation. How do you differentiate? Radiation, there's no medium. Okay, and it can travel through vacuum. So, and radiation is very special. You will notice this one, conduction, you need a touch. Convection, you need a movement up down. But for radiation, it's actually 360 degree. Okay, there's no specific direction. So the sun can provide us the heat in all direction. Okay, and there's no specific direction. So you notice, we look at the question now. So which is the best form? Okay, hot air, actually something that's heated here, the hot air rises. So the hot air, if it rises, it cannot go down. So we can safely say that convection is up, because hot air rises, cold air which is less dense will rise, cold air will sink. So convection is out, because I want it to move down. Okay, what about conduction? Conduction is also not possible because there's no physical touch. Remember just now when we explained there's a need for it to move, to have a touch. So these two, especially the heat source and the bread, is actually not touching each other. So conduction is also out. What about evaporation? Evaporation is actually not relevant here because evaporation is actually not a form of heat transfer. The form of heat transfer, recall just now, is three types: either conduction, convection, or radiation. So Evaporation in this case is not relevant. So the best answer that we have is actually radiation, okay, which is option A. Why? Because just now I already explained. Radiation, the heat source can transfer heat in all directions, 360 degree, up, down, left, right, center. Okay, so in this case, if my heat source is at the top, so it can definitely transfer heat energy downwards. Okay, which is how radiation can be can transfer heat energy. So the best answer for question 13 is A. Okay, so let's now move on to question 14. Okay, for question 14, this question was a bit complicated, but we can recall it's actually a topic of energy. How do I know it's energy? Because there's actually a swing. This pendulum bar is actually swinging from here all the way down to this V here. So the question is asking for the speed, which is the symbol V. Okay, so in this case, you cannot use the formula for acceleration because there's no acceleration given to find speed. Okay, you are not given the distance. The distance moved is actually this circular distance, and this circular distance is not even given to you. Okay, so the best way to solve this question is actually trying to recall this topic of conservation of energy. Okay, what does conservation energy says? You recall this original bulb is actually at the top. Can you see? It started at the top and then it moved down to the bottom. Okay, it moves down. So something at the top, we have this energy called the top. Okay, top position. You have this height difference. So height difference is actually a GPE. So at the top, the object actually possesses gravitational potential energy, which is mgh. As it swings down from this position down, it actually loses height. So when it loses height, it actually loses GPE. So when you lose GPE, okay, as you lose height, you actually, based on conservation energy, assuming there's no other energy loss such as sound and heat, you actually will gain Ke. Okay, so you lose height, you will gain Ke. Ke is actually related to the formula. Ke is actually equal to half mv squared. So we can actually form an equation called, in this case, loss in GP equal gain in Ke. So actually my mgh is actually equal to my half mv squared. So I can actually cancel my mass. So if I want to find speed v, if I simplify the equation, okay, I can cancel my mass because my mass is the same on both sides. So I can cancel my mass. So my v, actually I can just say that my v, if I just do my maths, is actually a square root of I bring my 2 up, 2gh. So in this case, my v I just substitute 2 times, in this case my g on earth is always 10. Okay, g is gravitational field strength, and my height that I've moved just now, you recall, the height where it has moved is actually 0.8 meters. So this is actually 0.8 meters. So this is the length of my string. So this is actually my height. Height is actually 0.8. So in this case, I must times 0.8. So if I press my calculator, I get my answer, which is 2 times 10 times 0.8, 16, square root 16. So if I square root 16, actually my answer will be 4 meter per second. Okay, square root 16 is actually 4. So my answer will be 4 meter per second, which is option D. Okay, this is actually, question 14 is actually quite a complicated question because some students can't see the link between, which is conservation energy, which is you lose height and you will gain speed. So you lose GPE, you lose height, you will gain speed. So this is how you will solve this type of question. Okay, so we have finished page 5. So we'll stop here first.